Hey guys, welcome to the geometry video notes for section 1.4. Today our learning targets are to classify polygons by the number of sides and find perimeters and areas of polygons in the coordinate plane. Before we jump in, let's take a look at a few definitions. Polygon is simply a closed plane figure. In other words, a two-dimensional figure formed by three or more segments. These are the sides. Those sides intersect at vertices. On the right hand side you see five-sided figure, which is a pentagon, and that pentagon is closed. It's made up of those five sides. Those sides meet at these points, and those points are called vertices. This is vertex D, vertex E, vertex A, so on and so forth. A convex polygon is a polygon such that no line of the polygon contains a side that lies inside. So over here on the right hand side you see this polygon. It is convex because if you draw a line through any of the sides, none of those sides fall in the interior. When you contrast that with a concave polygon, this is a polygon that does have a line that contains a side falling on the inside of that polygon. So you'll notice that this line here passes through this side, it contains that side, and it falls inside that polygon, so it's concave. Another way to think about that, it's got this little dent here. Kind of looks like the opening to a cave, so it's concave. A diagonal is a segment that connects two non-adjacent vertices. Those are just vertices that are not right next to each other. So here is a segment that connects two vertices that are not adjacent. That's a diagonal, diagonal BD. Here's another example, diagonal AD. All right, pause the video for a second, copy down these common classifications for polygons with their various side numbers. Then we'll jump into example one. All right, now that we got example one ready to go, here we go. We're going to classify the polygon by the number of sides and tell whether it's convex or concave. First up, we got the number of sides is 4. So even though it looks like a rectangle or parallelogram, this is going to be classified as a quadrilateral. It has 4 sides. If we're drawing lines through those 4 sides, none of those lines are going to fall inside that quadrilateral. So we say that this is convex. Next up, we've got a 6-sided figure. 6 sides is a hexagon. And if we were to draw a line through a couple of these sides, we would see that that line does fall on the inside. And it has these little dents here, kind of like caves. So this is a concave hexagon. Our next example is actually a tricky one. This is a circle. It's actually not a polygon. Remember, polygons are made up of 3 or more line segments that connect at vertices. Here there are no vertices, there are no line segments. It is not a polygon. All right, some perimeter and area definitions. Perimeter, remember, is just the one-dimensional length around a polygon. In order to find the perimeter, we are going to add the sides up. So know all the side lengths are and add them up. And to find the area, it is a two-dimensional space within the sides of a polygon. Below here are a few common perimeter and area formulas for these 4 types of polygons: triangle, square, rectangle, and parallelogram. Perimeter is just adding up the sides. For a square, all sides are the same, so we take one side multiplied by 4. A rectangle has 2 pairs of congruent sides, so we double one of them and add it to twice the other. Get the perimeter. And then for parallelogram, we're not going to concern ourselves with the perimeter of that for right now. The area formula for a triangle is base times height divided by 2, or 1/2 base times height. And the important thing to remember here is that your height and your base need to intersect at 90 degrees. They need to be perpendicular. That is true also for our parallelogram. The base and the height need to be perpendicular. That height is the perpendicular distance between those 2 parallel sides in a parallelogram. Okay, area formula for a squared. Once again, it's just base times height, and since base times height are the same, we say that is the side length squared. And area for a rectangle is base times height, or another way of saying that is length times width. All right, let's get into a few examples here. Example 2 asks us to find the perimeter of the square ADEF that is graphed in the coordinate plane, and then to find the perimeter of triangle ACD that is graphed in the coordinate plane, and then to also find the area of those two figures as well, and in the end to add up and find the total area of this 5-sided polygon. Okay, let's start off by taking a look at the perimeter of the square. I know that the perimeter of a square is 4 times the side length. So all I need to do is find one side length and multiply it by 4. Let's use side length FE. It's on the slant here between 0, -4 and -4, 0. So to find the length of that, I'm going to use the Pythagorean theorem, and I'm going to create this right triangle where my two legs are both 4 units long. My hypotenuse then will be the side of that square. So I'm going to say 4 squared plus 4 squared is equal to c squared. That gives me 16 plus 16, or 32, is equal to c squared. Now I'm going to take the square root, and I'm only going to take the positive value here, c, or in other words the length of that side of that square, the square root of 32, which is 5.65. All right, now that's the length of one side of the square. Remember, my perimeter is going to be found by taking 4 times that side length, 5.65. When I do that, let me just do that on my calculator here. That is going to give me 22.6, rounded off to the nearest tenth. All right, so there's my perimeter. We're going to call it units because we're just measuring length. Let's now talk about the perimeter of triangle ACD. So up here at A, all the way over to C, this is a nice one because this is just a horizontal line. I can count my boxes. In fact, I'll write that down right now. AC is equal to 6. Just counting over from 0, 4 to 6, 4, that gives me 6. All right, then I'm going to come down from point C down to point D, and then point D back up here to point A. Well, from A to D, that's just one of the side lengths of my square, and I already found that in the previous part of my problem. So I know what side length AD is. It is 5.65. All right, the only side I still need to find then is this side D to C. Well, once again, I'm going to create a right triangle and use Pythagorean theorem. I'm just going to change the color here so we can see that. Those two red segments now are the legs, and this leg is 2 and this leg here is 4. So I'm going to use Pythagorean theorem to say 2 squared plus 4 squared should be equal to c squared. And the c that I'm talking about here is this slanted line that I'm trying to find the length of. So that's 4 plus 16, that's going to be 20, is equal to c squared. Taking the square root of 20, let me try that here. Taking the square root of 20 is going to give us 4.47. All right, so here is my segment, DC, 4.47. To find the perimeter, we're going to add up all of those. So we'll let the calculator do the work here. And that's going to give us a total of 16.1. So we'll say the perimeter of triangle ACD is equal to 16.11. All right, and that's in units as well. All right, let's keep moving on here. Now we want to find the area of square DEF. Well, remember the area formula for a square is just the side length squared. Well, we know the side length is equal to 5.65, or actually another better way of thinking about this, let's go back up to here. Our side length is actually the square root of 32. So I'm going to take the square root of 32 and I'm going to square it. And that's going to give me an area of 32. And now this is going to be units squared. All right, finally we want to find the area of triangle ACD. So if I go back up here to my picture, they actually give me the height here and the base. The base and the height, remember, are always perpendicular, so those are the highlighted sides there. And my base is going to be this distance from A over here to C. That's going to be 6. And my height is going to be 1, 2, 3, 4. So I can take the area of that triangle to be 1/2 6 times 4. And that's going to be half of 24, which is going to be 12 units squared. All right, and lastly here, we want to find the total area. Total area is just going to be the sum of the area of the triangle and my square. So I'm going to take 12 and 32, add that up. That gives me 54 units squared is my total area. Just one more example today here. We want to find an expression for the perimeter in the area of the rectangle that has a width of x minus 4 and a length of x plus 2. So let's start off by drawing a picture of what we got here so we can get a good visual. And we'll just make those nice straight lines here as best we can. And close enough. There's our rectangle, and we know opposite sides are going to be congruent. So this is x plus 2, this is x plus 2, this is x minus 4, we got x minus 4. All right, so to find our perimeter, remember we're going to add up all the sides. So let's start by adding up all the x's. We got x plus x plus x plus x. That's going to give me 4x. And then we're going to add up all of the positive constants and the negative constants. So plus 2 minus 4, that gives me negative 2. Plus 2, that brings me back to 0. And then we got negative 4 again. So we have 4x minus 4 is the expression for our perimeter. And we'll just say that that's in units. And then next, we got to find the area. Well, area, remember, is found by taking our dimensions and multiplying them to each other. So I'm going to have x minus 4, the length, times x plus 2, which is the width. Now we need to simplify this by doing our distributive property. So that's x times x, which is x squared, x times 2, which is 2x, negative 4x, and negative 8. Combining our like terms in the middle, we get the expression x squared minus 2x minus 8, and now we have units squared. There is our expression for the area of this rectangle. Alrighty guys, that wraps up our Geo notes for today.